Hi बच्चों, this is lecture 7 of number theory. Here we will discuss part 3 of HCF and LCM and we will solve amazing questions. One of the toughest questions that can be asked from HCF and LCM only. So we will discuss 5 or 7 questions approximate so that you will have a clear grasp of HCF and LCM, and next time whenever you see the questions you won't get difficulties in this. So let's begin. First question says, find the number of ordered pairs of positive integers x comma y that satisfy the equation 1 by x plus 1 by y is equal to 1 by HCF of x comma y plus 12. Amazing. This is nice question. This is of IOQM level. You can say it can be asked. Why? Because find the number of, so the answer will be either single digit or 2 digit. Let's see. Find the number of ordered pairs of positive integers. What we are required to do? We are required to find ordered pairs that satisfy this 1 by x plus 1 by y is equal to 1 by HCF of x comma y plus 12. Now again, this is a part of Diophantine equation. When we will discuss this, we will discuss in detail what our Diophantine equation is. Now here let us consider, let h is equal to HCF of x comma y, say. Now, so x and y we can write in terms of h. We can write in terms of h. Now, what is the strategy here? The strategy is simple, that we are required to solve the equation. But how? Let's see step by step. So h is HCF, x and y we can express in terms of h, y. X can be written as, say, h of a, y can be written as h of b, where a, b belongs to some positive integer z plus, and also HCF of a comma b is 1, that is their co-prime. Okay. Now if this is the case, so we can substitute onto the original equation. So this will be 1 by h a plus 1 by h of b is equal to 1 by HCF of x comma y, that is h plus 12. So what is the value? If I take the LCM, so this will be, say, h a plus b is equal to, or we can write directly cross multiplying, h plus 12 is equal to h square of ab. Now h, since h belongs to z plus, we can cancel h here. So ultimately this becomes a plus b into h plus 12 is equal to h of ab. This is the case. Now understand one thing. Here we have to do some logical conclusion. Why? Because you will say, sir, there is only one equation and there are so many multiples. It's nearly impossible to solve. Actually it is not. This is a great strategy. Now why it is not impossible to solve? We have to look at the cases. What cases we can do? We know that we can partition it a into h plus 12 plus b into h plus 12, and this is equal to h of ab. Now think of one thing, left hand side and CRHS. Now in LHS we can say one thing, that this HAB, it means this HAB must divide what? For example, here if these two are equal, okay, so what am I saying? If these two are equal, we can do one thing, that see, A is dividing. If I substitute here, if I need to find the HCF, which is an integer, so I can write like this, AB, that is h plus 12. If I divide by AB, so this will be divided by B, and here it will be h plus 12 divided by A. It means, and h belongs to z plus, it means h plus 12, B must divide h plus 12, also A must divide h plus 12 from these two conclusion. If they don't divide, students, so what is going to happen? They will not be perfect integers. So if they will not be perfect integers, how can be equal to some integer? Now think of one thing. So B divides h plus 12, A divides h plus 12, then and HCF of a comma b is 1. A comma b is 1. So therefore we can say if A divides B, A divides C and B divides C, so AB will divide C when they are co-prime. So this is true. So what we can consider? Now we can consider then H plus 12 will be equal to sum K AB. H plus 12 will be equal to sum K into AB. So if I substitute into the original equation, let's say this was original equation, so let's consider this as 1. What we need to do, we can substitute here and say this is 2. So where we are gonna substitute, we know H plus 12 is equal to KAB. So basically if I substitute here, yeah, H plus 12 is equal to KAB, then substitute in 2, so A plus B into KAB will be equal to HAB. So AB is positive, AB can be cancelled. So basically what is left out? So left out value is K into A plus B. Now only H was, yeah, we got H plus 12 is equal to KAB. Then K into A plus B is equal to H. So this is the value that we are getting. Now what else can be done? What else can be done? Now it means H is equal to K A plus B. Now again here is the original equation. See, all H value can be considered in terms of A plus B. Yes or no? So if I need to substitute K into A plus B is equal to H, then we can do one thing. Yeah, what needs to be done? We got A plus B, K into A plus B is equal to H. What else can be done? We can do from here, that is K into A plus B was, yeah, H is equal to this is equation 3. Let's consider this as equation 4. So what we required, we don't require H. That is our strategy. So if we don't require H, we can substitute H plus 12 as K into A plus B plus 12 is equal to KAB. So here we get the value only in terms of K and AB. So basically this 12 will be equal to K into AB minus A minus B. Now this is a part of SFFT, Simon's favorite factoring theorem. So 12 can be written again strategically as K, take A common, this is B minus 1, again minus B minus 1. So basically again I have substituted plus 1, so it can be taken as minus 1 also. I added plus 1, so I subtracted minus 1 so that both cancels out. So basically this becomes A minus 1 into B minus 1 into K is equal to 12. Now basically one thing, A, B, K, these are positive integers. Again what we can say, K and A minus 1 into B minus 1 must be integral factors, of 12. Now we can find out, must be integral factors of 12. So if these are integral factors of 12, then we can find using the cases what are the possible values that can be taken. Now, so again one thing, can A be 1 or B equal to 1? So if A or B is equal to 1, then this value becomes minus 1, which is not possible. So A is always greater than 1, B is always greater than 1. These two cases are valid. Okay. Now if these two cases are valid, let's check out one of the thing. First consider, now I have taken A is equal to 1 or B is equal to 1. What are the factors of 12? 1, 2, 3, 4, 6, 12. We have to take all the cases. Now instead of taking for K, we will go for A minus 1 into B minus 1 minus 1, let's say is equal to 1. It means K was 12. It means for this case K was 12. Okay, so 12 into 1 is 12. Now, therefore, this becomes a minus 1 into b minus 1 is equal to 2. Now, if a minus 1 into b minus 1 is equal to 2, there is only integral solution this can be written as 2 into 1. So, a minus 1 is equal to 2, b minus 1 is equal to 1. First case 2 into 1. Acha, again second case you can say, sir, this can be 1 into 2. A minus 1 is equal to 1, b minus 1 is equal to 2. So, either 3 comma 2 or 2 comma 3 both can be the solution. But let's check. Now, these are the values of a comma b. What we considered earlier, HCF of a comma b must be equal to 1. Otherwise, that will not be a valid solution. So, 3 comma 2 has HCF 1 indeed. So, it means this is equal to, this is a valid solution. This is valid solution. So, valid solution. ठीक है, valid solution. Next, case 2. So, in case 2, what can be considered? कि a minus 1 into b minus 1 minus 1 can be taken as 2. So, here k will be equal to what? 6. Therefore, 6 into 2 will be equal to 12. Yes, true. See this original equation, and this can be considered as equation number 5. So, I am talking of 5. If this is 2, this will be 6, so that overall it gets 12. Now, a minus 1 into b minus 1 minus 1 is equal to 2. So, k कितना हो गया? 6. Next, if this is the case, then a minus 1 into b minus 1 is equal to 3. Again, so 3 can be factorized as 3 into 1. So, there will be two possible cases. What are the possible case? A minus 1 is equal to 3, b minus 1 is equal to 1. Again, a minus 1 is equal to 1, b minus 1 is equal to 3. So, this gives the cases as 2 comma 4 and this as 4 comma 2. But there is a problem. HCF of 2 comma 4 or slash 4 comma 2 is not equal to 1. Why? This is equal to 2. So, this case is wrong, invalid pair. Next, case 3. So, what is case third? A minus 1 into b minus 1 minus 1 can be taken as 3. So, therefore, k will be what? 4. So, again this as a minus 1 into b minus 1 is equal to 4. Now, 4 can be written as many ways. So, a minus 1 into b minus 1, 4 can be written as either 1 comma 4, 2 comma 2 or 4 comma 1. So, basically for a minus 1 is equal to 4, b minus 1 is equal to 1. Next case, a minus 1 is equal to 2, b minus 1 is equal to 2 or a minus 1 is equal to 4. Sorry, I have taken the cases. So, 1, b minus 1 is equal to 4. So, this can be the case. Again, here this will be 5, sorry, a minus 1 was 4 here. I am sorry. So, a minus 1 will be 4 and this will be 1. So, a is 5, b is 2. Again, this will be 3 comma 3. Again, this will be 2 comma 5. So, but tell me, what is HCF of 3 comma 3? HCF of 3 comma 3 is not equal to 1. It's 3 actually. So, this is invalid case. Rest 2 is valid case. It means HCF of 5 comma 2 is equal to HCF of 2 comma 5, that is equal to 1. So, this case is also valid. So, next case 4. In case 4, what we can do? Case 4, we can say a minus 1 into b minus 1 minus 1 is equal to 4 and hence k will be equal to 3. So, therefore, a can be written as a minus 1 into b minus 1 can be written as 5, which can be factorized as 5 into 1 or 1 into 5. So, basically, a minus 1 is equal to 5, b minus 1 is equal to 1, a minus 1 is equal to 1, b minus 1 is equal to 5. So, basically, this case is 6 comma 2 or 2 comma 6. So, HCF of 2 comma 6 is not equal to 1. Okay? So, therefore, this case will be invalid. Next, case 5. So, in case 5, a minus 1 into b minus 1 minus 1 will be equal to what? So, this will be equal to, I have taken the cases of 4. So, again this will be 6. So, then a minus 1 into b minus 1 is equal to 7. Then So a minus 1 into b minus 1 is equal to 7. Next case, 7 can be written as 7 into 1 or 1 into 7. So therefore a minus 1 is equal to 7, b minus 1 is equal to 1, a minus 1 is equal to 1 and b minus 1 is equal to 7. So what is the case? 8 comma 2 or 2 comma 8. Now HCF of 8 comma 2 is not equal to 1. So this case is again invalid. And the last case says case 6, a minus 1 into b minus 1 minus 1 will be equal to 12. So a minus 1 into b minus 1 will be equal to 13. So again 13 can be factorized as 13 into 1 or 1 into 13. So therefore one pair I'll write directly, one pair a comma b will be either 14 comma 2 or 2 comma 14, but HCF of 2 comma 14 is not 1, so it is 2. So again this is invalid case. Here what was k was 1. So what are the valid case? Case 4 was invalid, case 5 was invalid, case 3 is valid only for 2 case, k is equal to 4, then this will be the values. Okay, so there are possible values in case third. Again in case 2 it is not there, case 1. So there are only two possible cases. So if a comma b is equal to 2 comma 3 and then a comma b is equal to 3 comma 2, again a comma b as 2 comma 5 and b comma a as 5 comma 2. These are the only possible cases. So if a comma b is 2 comma 3, then this was case first. So here it was k12, again there was k12. Okay, and now for this case this was 2 comma 5 was in which case? 2 comma 5 was in k equal to 4. So k is equal to 4 in this two case. Now if we know a comma b, only 4 possible pairs. But can you tell me what will be the value of x and y which we considered earlier? This is amazing question. Amazing. Find the number of ordered pairs x comma y. So what was x comma y? Now for x comma y we can consider one case. We know how to find x comma y here. First, can we find what is the value of x comma y? First let us find h. Now how do we find h when we are given kab? Is there any relation in any equation? If we know yes, if we know kab we can find h. So basically it can be written as h is equal to k into a plus b. So in the first case this will be 5, that is 60. In the second case, let me rub this off. We can do one thing, use another one. Yeah, here it is again 12, 60. H is 60, h is 60 here, and for the rest of the two this will be 4 into 7, that is 28 and 28. So basically x comma y was HA HB. So first pair becomes 62 120 180, second pair becomes 180 120. Again third pair becomes k is equal to 4. So that is we have got 28. So x HA 28 56 and 140. So 56 comma 140 or 140 comma 56. Amazing. These 4 properties shall be taken care of, and there are total 4 ordered pairs. 4 ordered pairs x comma y. 4 ordered pairs x comma y. Done. This is really a nice question. So the way of counting, the way it looked daunting actually, and the way it was solved systematically. First what we did, we took HCF as h, and then we systematically approved of the ways that it can be solved easily. Now the cases which HCF a comma b equal to 1 was not coming was strike down, and then Rest of the cases were taken care of. So this is amazing question. Next, it says let a, b, c be positive integers. Given the following conditions, LCM of a comma b is equal to 1800, LCM of a comma c is equal to 600, LCM of b comma c is equal to 180. Find the number of ordered triplets a comma b comma c that satisfy these conditions. So now, number of ordered triplets that satisfy this condition. Now again an amazing question, amazing, the best question for IOQ. Given you are given the LCM of individual one ABC, matlab taken pairwise, you are required to find कि what are the possible number of ordered triplets that can satisfy this condition. Again, I am telling you in number system, if you are good with your HCF and LCM, your half part is conquered. Why? Rest of the things, there is one thing that you need to understand very well, modular arithmetic. But apart from modular arithmetic, HCF and LCM is quite lengthy, quite interesting, with some of the very best questions that can be framed. So this is one of the masterpiece here. Now, if I say first, what will be the strategy? Actually, we will see, can we check out the prime factors of 1800, 600 and 180? Okay, the prime factors are taken care of. Now, can we systematically write A, B, C separately in terms of these prime factors? Yes, we can take some powers. Can we decide over the powers then? By conclusion, if we decide over the powers, we can frame the cases. That is our strategy. So first, let's prime factorize. So 1800 is written as 900 into 2. So 2 into again 2, 450, 2, 225. So 2 to the power 3 and 225 is 15 ka square. So this will be 3 ka square into 5 ka square. Correct? So 2 ka cube into 3 ka square into 5 ka square. 600 can be written as 2, 300, 2, 150, 275. 2 ka cube into 75, that is 25 into 3 into 5 ka square. Correct? Next 180, 36 into 5. So 2 ka square, 3 ka square into 5. Done. Now this is the case. First, we are done with this. Second, I said, can we write A, B, C only in terms of this exponent? Yes. So let's say A is equal to 2 per power x1, 3 per power x2, or we can write 3x1, we will write only for 2. So 3 per power y1 and 5 per power z1. Only this can be framed with A. Why? Because there are only exponents of 2, 3 and 5. Only 2, 3 and 5 prime factors for A, B and C. See, we don't know whether A will be whether 2 will be there in A or not, but we can deduct that. So here is B. Now for B this will be 2 to the power x2, 3 to the power y2, 5 to the power z2. Now C 2 to the power x3, 3 to the power y3, 5 to the power z3. Done. Now A, B, C are done. Written this way. Now how do we find LCM? So LCM ABC is equal to maximum exponent of each prime, maximum exponent for each prime, Now what we can do, we can create a system of equations for each prime. It means we can create system of equations for each prime. Each prime means I am talking of 2, 3 and 5. For each prime, that is 2, 3 and 5. Done. Now, so what does this imply? It implies, let's see, exponents of prime 2. Now, if we see exponent of prime 2, so first one is x1, x2, then x2, x3 and x1, x3. Why? This is LCM of A, comma B, B, comma C, and this A, comma B, this A, comma C. This is A, comma B, this is A comma C, and this will be B comma C. So system of exponent for prime will be, first is x1 x2, I am talking of maximum. Then we'll talk of maximum A comma C, that is x1 x3. Why? I am talking only of exponent of prime 2. So first one is x1 x2, then x1 x3, and last is x2 x3. So maximum of x2 x3. How would we take the choices? So maximum of x1 x2 will be, see here, in for A comma B it will be 2 to the power 3, and for the second one A comma C, again it will be 2 to the power 3, so exponent will be 3. But for B comma C it will be 2. Okay, so this is exponent is 3, maximum this is 3, but this one is 2. Where did it come from? LCM A comma B. Again this comes from LCM A comma C, and this comes from LCM B comma C. Now there is very interesting thing here. If you can see, maximum of x2 comma x3 is what? Maximum of x2 comma x3 is equal to 2. Now what does this conclude? This concludes x2 is less than equal to 2 and x3 is less than equal to 2. This is the conclusion. Now if we look at maximum of x1 comma x2, so this is given as 3, but one thing, x2 is less than equal to 2, so which one is 3? So x1 must be 3, x1 is equal to 3. This is the conclusion. Also if we can see that it is written 3 comma x3, that is 3, correct. Second one is correct. Now check the third one. It's written maximum of x2 comma x3 is equal to 2, and we know that x2 is less than 2, x3 is less than equal to 2. So what are the case possibility here? We can say there can be a combination. So either it can be 2 0, either it can be 2 1, either it can be 2 2. Why? Because even if I take 2 2, maximum of 2 comma 2 will be 2. Again I can take 1 comma 2, again I can take 0 comma 2. So how many possibilities? 5 possibilities. So here there are 5 possibilities for exponents of 2. Now what are the possible exponents of 3? It means for prime 2, how many choices? There are 5 possibilities. So for prime 3, similarly for prime 3, exponents of prime 3, how would we decide? So we can check out initial condition. So for A comma B its maximum exponent is 2, for B A comma C it's 1, and for B comma C it's 2. So again here maximum of y1 comma y2 it is 2, maximum of y1 comma y3 that is 1, maximum of y1 comma y3 is 1, maximum of y2 comma y3 it is 2. Done. Now these are the cases, possible cases. So if we see maximum of y1 comma y3, I am taking the smaller one, this is written as 1. It means y1 is less than equal to 1, y3 is less than equal to 1. Super. But there is another condition. What? Maximum of y1 comma y2 is written as 2. Now if maximum of y1 comma y2 is 2, y1 is less than equal to 1. What does this imply? This implies that y2 is 2. This implies y2 is 2. Now again if I check any of the equation, which one? Let's say y1 y3 again. So maximum of y1 y3 is 1. Now y1 is less than equal to 1 and y3 is less than equal to 1. So what are the possible conditions here? Either it can be 1 0, either it can be 0 1, or either it can be 1 1. So there are 3 possibilities. Done. So 3 possibilities for exponents of 3, done. Now next we can check for exponents of 5. Now we can check for exponents of prime 5. So exponents of prime 5. Now what are the cases? Maximum, let's see here, for 5 it is maximum for A comma B it will be 2, maximum for A comma C 2, and maximum of b comma c is 1. So what are the possible conditions for exponent of prime 5? Maximum z1 comma z2, that is equal to 2. Maximum of z1 comma z3, again it is 2. Maximum of z2 comma z3, so again it is 1. Now please understand one thing. We'll take the smaller value and we'll see if maximum of exponent of z2 comma z3 is 1, then what does this imply? It implies z2 is less than equal to 1, z3 is less than equal to 1. But if I check out maximum of, say you take any other value, say maximum of z1 comma z2, if I choose it as 2, where z2 is less than equal to 1, then what is the other condition? Z1 must be 2. Z1 must be 2. Now if Z1 is 2, then other conditions are verified. So let's say maximum Z2 Z3 is what? Maximum Z2 Z3 is 1. Okay, so Z2 is less than equal to 1, Z3 is less than equal to 1. We have concluded from here. Now, so what are the possible condition? Again 1 0 1 1 0 1. So how many choices? Three possibilities for exponents of 5. Three possibilities for exponents of 5. So now what are the total choice? So total number of triplets. So what is the total number of triplets? So again, how many choices for 2? There are 5 possibilities, 3 possibilities and 3. So 5 into 3 into 3 is the total number of choices, that is 45. So answer will be what? 45 is the total number of choice. Done. Amazing question. Next. So here what was the question asked? The question asked was find the number of ordered triplets that satisfy this condition. So there are 45 ordered triplets that satisfy this condition. Done. Now next question says let A and B be positive integers. Okay, let A and B be positive integers. It means AB belongs to Z plus. Okay, HCF of A comma B is given as 12. Okay, the number of positive divisors of their product. Let me, yeah, yes, this is perfect. The number of positive divisors of their product AB is exactly 15. Okay, it means let's say divisor can be written as D. D of A comma B is given as 15. What is the value that they are asking? Find the number of positive divisors of the LCM. It means they are asking what can be the number of positive divisors of their LCM. Okay, so we will be talking of LCM A comma B and we'll be checking number of positive divisors of LCM of A comma B. That is what they are saying. Okay, done. Now let's check out. D of A comma B is 15. Okay, so first let's simplify. HCF of A comma B is written as 12. 12 can be written as 4 into 3, that is 2 square into 3. Done. Now D of AB is 15. So what we can say, let A. Now A and B can be written in terms of 12. How? A is 12x, B is 12y, where x, y are co-prime positive integers. Done. It means HCF of x comma y is equal to 1. Done. Now therefore what is the value of A comma AB? AB will be 12x into 12y, that is equal to 144xy, which is again equal to 36 into 4, that is 16 into 2 to the power 4 into 3 ka square, and that is xy. Done. Now it is given D of AB, that is divisors of AB, is 15. Okay, but how do we find the divisors? Remember the previous case on the beginning of theory of numbers, what we discussed? If D of n for any n belonging to Z plus, where n can be prime factorized as P1 per power E1 into P2 per power E2 into P3 per power E3 and goes on is given by d of n, that is equal to E1 plus 1 into E2 plus 1 and goes on. Now d of AB, according to question is mentioned 15. D of AB is given as 15. So how do we proceed? 15 can be written as 15 into 1 or either 1 into 15, whatever, or 5 into 3 or 3 into 5, whatever. This two cases. That is the only possible case where it can be broken down in terms of integers. Now, so let's say case first. So if I choose say E1 plus 1, that is E1 plus 1, let's say this is equal to 15. So what will be E1, which implies E1 is equal to 40. So therefore AB will be equal to what? AB will be equal to P to the power 14 for some prime P. For some prime P. Done. Now, so what is our expression? So AB is equal to P to the power 14. Now it has two distinct prime factors. AB already is known by the prime factors. What were the prime factors? 2 to the power 4 into 3 square into xy. The problem is it has two distinct factors, two distinct prime factors. And what are those prime factors? What are those? Those are 2 and 3. But here we are only saying that there is only one prime factor. So this case is impossible. This case becomes wrong. Now case 2. So in case 2, what we can say, that E1 plus 1 into E2 plus 1, it is given as 5 into 3 or 3 into 5, whatever. So if I compare, E1 will be equal to 4, E2 is equal to 2. So which is of the form, therefore which is of the form AB is equal to P1 per power 4 into P2 per power 2. So therefore what is our expression? 2 to the power 4 into 3 chi square into xy. That was AB. So this is equal to P1 per power 4 into P2 per power 2. Now here what happens if we start comparing? P1 can be 2, P2 can be 3 and xy is equal to 1. But xy is 1. Now if xy is 1, you will ask me, okay sir, how do we conclude that xy is 1? Why xy will be 1? See, first analogy. What was the question? The question was A and B are positive integers. HCF is 12. Number of positive divisors were given. So what we concluded, if HCF is given, A and B can be written in terms of AB, their HCF. So if A and B can be written in terms of their HCF, and we know how to find the number of divisors for any given positive integer. Now again, if these two are done, so basically we derive the cases. In one of the case, what we got exactly the value as P1 equal to 2, P2 equal to 3. But here xy is coming 1. Now, but is this correct? If xy is equal to 1 and xy belongs to z plus, we are required to see कि x equal to 1 and y equal to 1. But how? Why this is the case? Why xy is equal to 1? So let's see. Suppose if I say HCF of x comma y is 1, it means xy share no prime factors. Now if they share no prime factors other than 1, I am talking of other than 1, it means we can do the proof of contradiction. So let's say P is any other factor. So if P is any other factor, what is going to happen? So here p is any other factor 2 and 3 को छोड़ के, ठीक है, let's leave aside 2 and 3. So then what we can say, if we say AB is equal to 2 to the power 4 into 3 to the power 2 into p to the power 1, then what will be the number of divisors? P is any other factor, so I am writing only power 1. So again 4 plus 1 into 2 plus 1 into 1 plus 1. So basically this will be 30 and not 15. Done? It's wrong. Now if xy, there can be other case, if xy contains power of 2 or 3, power of 2 or 3, that is HCF xy is equal to 1. So we can say x is equal to 2 to the power k. Then AB will be what? AB will be 2 to the power, we already have got 4, so 2 to the power 4 plus k into 3 k square into y. So basically what is the number of divisors here? This will be, I can write here in a bit of space. So what is the number of divisors? So it will be 4 plus k plus 1 into 3 into divisor of y, some divisor of y. So this will be 3 into 5 plus k into divisor of y. Now 3 into 5 plus k. Now basically if this has to be equal to 15, so what we can say, that 5 plus k into d of y shall be equal to what? 5, that shall be equal to 5. But if k is greater than equal to 1, because k must be positive, then 5 plus k is greater than 5. So this is not possible, not possible. And even if it contains power of 3, it will not be possible. So the only case possible is when x equal to 1, y is equal to 1. Proved. So therefore what is the value, original value, what we were required to find? We were required to find the number of positive divisors of their LCM. So before finding LCM, what can be done? We can say what is A and B. So actually A will be 12x, that is 12. Why? Because x is 1, B is equal to 12. Again it is 1. So therefore LCM will be 12 itself, 12 comma 12, that is equal to 12. And 12 can be written as 2 chi square into 3 per power 1. So therefore what is the number of divisors? So number of divisors will be what? 2 plus 1, that is 3, and 1 plus 1, 2, that is 3 into 2 is equal to 6. So number of divisors is 6. Done. Next question says, next question says, let S be the set of integers in the range n greater than equal to 1 less than equal to 1000, for which HCF of 2 to the power n plus 1 comma 2 to the power 20 plus 1 is greater than 1. Find the number of elements in S. Super. Again an amazing question. What is the strategy? Now we are given some numbers 2 to the power n plus 1 and 2 to the power 20 plus 1. But the range of n is already given, that it lies from 1 to 1000. And it is being said that HCF is not 1. What is the number of elements? Okay. So how do we arrive at the solution? What is the strategy? See, it's being talked key numbers n, that is being from 1 to 1000, that we are required to find. But what? That HCF of 2 to the power n plus 1 comma 2 to the power 20 plus 1 is greater than 1. That is what we are required to find out. Now actually we know what is HCF. HCF is the biggest number that divides these two numbers without leaving a remainder. Yeah, correct. Now so think like this way. What is the trick here? Amazing trick, amazing. If this question is asked, this will be amazing one. Now see, HCF of, remember this, HCF of a to the power x plus 1 comma a to the power y plus 1 is always equal to a to the power k plus 1. But when when two conditions are met. First, under certain condition. So what is the condition? Condition is K must be HCF of x and y. ठीक है, x comma y. That is we can say K is equal to HCF of x comma y. What is the second thing? Second thing, if I divide x by k and y by k, both must be odd numbers. बोथ मस्ट बी ऑड नंबर्स, ये ऑड नंबर्स होना चाहिए. ठीक है, डन. नाउ अगर थर्ड कंक्लूजन, इफ x बाय k और y बाय k इज एन इवन नंबर, then HCF of a to the power x plus 1 and a to the power y plus 1 is equal to 1. Now this is always true. That's the strategy of this question. What I have said, K must be HCF of x comma y. I will tell you. What does this mean? Let's say suppose if I say 12 comma 18, say this is one of the number, that is x comma y. Now what is the HCF? K is equal to 6. So I am saying if it is like this, K both either must be odd or they can be an even. One cannot be even, another cannot be odd. Otherwise again the HCF will be 1. Okay, so if we choose, for example, if I choose 3, or we can choose 9, and we can choose say 15. We choose 15. Then let's say HCF of 9 comma 15 is what? That is HCF is equal to 3. So if I divide 9 by 3, that will be 3. 15 by 3, that is equal to 5. Now think of one thing. What I said, a to the power x plus 1 comma a to the power y plus 1. So what is a to the power x? So 2 to the power 9 plus 1 comma 2 to the power 15 plus 1. Now since both are odd, so what will be the HCF of these two? The HCF of these two will be a to the power. So a to the power, what is a? A here 2 per power k. So what is k? K is the HCF. 9 and 15 HCF is 3 plus 1. So this will be the HCF, that is 9. Again you can imply for the shorter numbers so that you will be able to understand it clearly. If I choose very easy numbers, for example, if I choose the value, let's say 3 and let's say 9. Okay, if I choose 3 and 9, then what is going to happen? HCF is 3 divided by 3, so this will be 1, this will be 3. Again what I am saying, if we choose 2 to the power 3 plus 1, 2 to the power 9 plus 1, the HCF will be, now this is 9, what is this? 2 to the power 8 is 256, so 513. So what we are talking of, what is the HCF? So this will be 2 to the power 3 plus 1. Yes, that is equal to 9. This is what is being said. Check out, the HCF of 9 comma 513 is equal to 9. Now we are not going into the details of the proof here, but this is amazing. HCF a to the power x plus 1 comma a to the power y plus 1, if it is of this form, remember the HCF is always a to the power k plus 1. Now k must be HCF of x comma y. So what we are saying, if I divide x by k and y by k and both must be odd number, then this is true. Otherwise if it is even, then HCF is always 1. Now we can also try one thing. Let's say 2 comma 4, suppose. So we say not 2 comma 4, we can say condition is that x by k and y by k must be odd numbers. So if it is even, then HCF will be 1. So let's check out. Suppose if I say 2 comma 4, what is HCF of 2 comma 4? That is equal to 2. No, for this the value will not be valid. Say 4 comma we can choose 8. Yeah, say 4 comma 8. So what is HCF of 4 comma 8? So HCF of 4 comma 8 will be what? 4. Now if I divide 4 by 8, this will be 1, this will be 2. Again let's choose 2 to the power 4 plus 1 and 2 to the power 8 plus 1. What will be the HCF? So what will be the value? This will be 70 and this will be 257. 7, 12, 14. So it's not divisible by any of the numbers. So HCF will be 1. HCF will be 1 in this case. It means if one is odd, another is even, again the HCF is 1. If both are even, then again the HCF is 1. Now based on this property, we can look at the question. Let me rub this off. These were the examples that I chose to illustrate whether this is true or not. Obviously it is true. Now please remember it, so that if bigger HCF is given, you will be able to find it very easily. Now think of one thing, what we are required to do. So for our problem, what is written here? A is equal to 2, that is A is 2, X is n, Y is 20. So in our case, A is equal to 2, X is equal to n, Y is equal to 20. Now what do we need? HCF 2 to the power n plus 1, 2 to the power 20 plus 1, that is greater than 1. So it means if we see the property, which form shall it be? It must be of the form 2 to the power k plus 1. So it must be of the form. So therefore HCF must be of form 2 to the power k plus 1, where what is k? K is HCF of n comma 20. So it means and conclusion, see the conclusion, both must be odd. If it was even, then there would be a problem. Now also we know n by k and 20 by k must be greater than n by k, 20 by k is even. Then HCF is 1. HCF equal to 1. So therefore n by k, 20 by k must be odd. That is, must be odd. Done. So if this is odd, then only we can analyze the condition. So let's see when, because we don't know n, we can go for 20 by k. So case first, 20 by k is odd. Now it means k divides 20 for sure. So what are the prime factors of 20? So the prime factors of 20 can be broken down as 2 ka square into 5. So it means what we are required to do, we have to take all the factors of 2. It means what 20 by k is odd. It can only be odd when all the powers of 2 is gone. So all the powers of 2 will be gone. So basically this will be it means k must be 2 square or more. Then only 2 square will be gone. Done. Now so if k must be 2 square or more, then basically what's going to happen? So 20 by k is odd, k divides 20. So 2 square is greater than 5, all the powers of 2 is gone, k must be multiple of 4. That is the conclusion. So basically amazing question, amazing. Now it means and so what happened here? So we can take cases. First, HCF n comma 20 is equal to 4. Why I have chosen 4? I said ki minimum k must be 4, because if it is not 4, the number will come even, and we don't want even numbers. See, I am telling you, if I choose 20 by 2, all the powers of 2 are not gone, so it will be 10, which is wrong. So 20 by 4, again, if I choose 20 by 5, it will become wrong. So 20 by 8, it doesn't cut the value. So 20 by 4 can be there only. So HCF of n comma 20 is 4. So it means n is equal to 4 into some multiple. 4 into some multiple. Yes. अच्छा, n by 4 is odd. ठीक है. So it means n is equal to 4 into some odd number. Some odd number. Now, what do we know? That again, n cannot be multiple of 20. N cannot be multiple of 20. Why? Because what do we need? HCF of n comma 20 we are choosing as 4. That is case 1. Case 1. HCF of n comma 20 is 4. But if I choose n as multiple of 20, can the HCF then, if I choose like this, then HCF of 20 multiple comma 20 will be not 4. So this case will be wrong. So n cannot be a multiple of 20. So if n cannot be a multiple of 20, it means now n is odd. N is equal to 4 into some odd number, 4 into some multiple. But I am saying not a multiple of 20. It means n cannot have 5 as one of their multiples. As one of multiples. It means n cannot be chosen, n, or we can say that odd number that we choose, it means odd numbers not multiple of 5 must be chosen. Done. Now, so what happens here? If m is odd number, then what we can say? So n can be 4 into m. Say m is odd. M belongs to odd number. Now n is from 1 to 1000. So basically 4m belongs from 1 to 1000. So m belongs to 1 to 250. Not 1 to 1 by 4 to 250. So it means m must be odd number. कहाँ से कहाँ? तो from 1 to 250 and not a multiple of 5. Done. So how do we count like this? First, we can count all the odd numbers. So basically, let me add the pages. Yeah. So here we can count first m 1, 3 till 250. So what is the total number? It will be 125. Why? 250 minus 1 divided by 2 plus 1. So that will be 250 minus 1. Yeah. So basically, no, not 250. The last odd number will be of course 249. So this will be 249. So 249 minus 1 divided by 2 plus 1. Obviously it is 125. So this is 125. Super. Now this is, if this is 125, we will talk of odd numbers. Not multiple of 5. So what are the multiples of 5? 5, 10, 15, and this can be till 245. Why? I am talking of, Okay, I am talking of odd numbers till 250, but we are not going to include 250. Why? Because we are only talking of odd numbers, so even we can't choose 10. So basically here we are going to choose only odd numbers that are multiples of 5. So basically 5 will be there, 15 will be there, 25 will be there, and so on. So what is the total value? So total value will be what? uh, 25. So difference is 10. So last value is 245. So that is 240 divided by 10 plus 1. So the total number is 25. So from case 1, therefore from case 1, how many values are coming? The values that are coming is total odd numbers, that is 125 minus 25, that is equal to 100. Now for case 2, case 2 is HCF of n comma 20 is equal to 20. Now that can be the only case. First is 4 and second will be multiple of 4, that is 8 is not divisible, 12 not divisible, 20 doesn't divide 12, uh, 12 doesn't divide 20, but 20 divides 20 again. So HCF of n comma 20 is 20. Then in this case what is going to happen? So n by 20 must be odd, and n is a multiple of 20, so what is the case? It means therefore n is equal to 20 into m. So basically 20m lies from 1 to 1000, so m will lie from 1 by 20 till 50. So what is the case? P must be odd number, and therefore this will be 1 3 till 49. Now therefore the value is 49 minus 1 by 2 plus 1, so therefore 25 numbers. So total case 25 numbers for this case, and there are it's being said कि n must be multiple of 20. So basically what we arrived, n by 20 must be odd. Done. So n is equal to 20m. So how many values? And n is a multiple of 20. So it's done. No, n is equal to 20m. So what are the values of m that we can select? Because we wanted m to be odd, so these are the only odd numbers that are possible. Therefore total values, therefore total numbers in element of S. So case 1 plus case 2. So basically this will be 125 by 100 plus 25, that is 125, and that's the answer. Next question says, let a and b be positive integers. Okay, let a and b be positive integers, that is ab belongs to z plus. The line segment connecting the origin to the point a comma b passes through exactly 9 integer coordinate points. It means there is some 0 comma 0, there is some a comma b. It's being said, suppose there is a line segment that joins this 2 points. Now it passes through 9 integral coordinates. Okay, 9 integer coordinates are there. Okay, including the endpoints. Additionally, the sum of the two integers a plus b is equal to 1/5 of their lowest common multiple. Find all possible values for the sum a plus b. Amazing. Again, a very nice question for IOQM. Now, how would we go for it? Say here, what we are going through from 0 comma 0 to a comma b, we are going. Now how do we find the number of integer points? So number of integer points will be number of integer points from 0 comma 0 to a comma b will be given by HCF of a comma b plus 1, that is given by HCF of a comma b plus 1. But why? Let's check out. Now suppose if I am joining from 0 comma 0 to suppose joining from 3 comma 3. Okay, so how many integer points can we go through? Suppose if I am going from 1 1, 2 2 and 3 3. So basically HCF of 3 comma 3 is what? 3, and there is plus 1 4. So of course we are passing through 4 integral points. We can check out again the value. This is very important conclusion from here. Suppose we are going from 4 comma 3 and I joined from 0 comma 0. Suppose uh, how many integral points will it pass through? It will pass through 2 integral points only. How do we find out? We find using the slope technique. But why? Because HCF of 4 comma 3 will be equal to what? 1. So 1 plus 1, total 2 integral points. 2 integral points means 0 comma 0 and 4 comma 3. It means there is no other integral point that passes through in between. Okay, so this is the value. Now again, what is the reason? We can see the slope is 4 by 3. So again, can there be any other integral points in between 0 comma 0 to 4 by 3 where it means any other integral point must be a multiple of 3. But suppose if I choose 3 comma 3, but its slope will not be equal to 4 by 3. So that is the problem. So no such point exists. Therefore we can say number of integer points is equal to HCF of a comma b plus 1, and our answer is done. Why? We got the HCF now. HCF of, according to question, HCF of a comma b plus 1 is given as 9. Why? They are saying 9 integer coordinates. So now therefore HCF a comma b, which implies HCF of a comma b is equal to 8. Done. So if HCF of a comma b is equal to 8, then let h is equal to HCF of a comma b. We can write a and b in terms of h. So a will be 8h, and b will be or instead writing of h, we can say 8. So HCF is 8, that is equal to 8. So therefore a can be written as 8x, b can be written as 8y. Now xy belongs to what? Xy belongs to z plus, and HCF xy is 1. Done. Now therefore LCM of a comma b will be what? LCM of a comma b will be h into xy, that is h into xy. Why? It's saying lowest common multiple. Lowest common multiple means HCF into this xy. Minimum, it will be HCF into what else is remaining. This is xy. So therefore this will be 8xy. This will be 8xy. If you don't understand how, see here, suppose I am taking 6, so this is 2 into 3. Again if I take 9, this will be 3 into 3. So what is HCF of 6 comma 9? This is 3. So what will be the LCM? How do we find the LCM? Now 1 3 is already taken, so we can choose another 2 from here, we can choose another 3 from here, and 3 3 9 to 18, that will be the value. So basically we choose the HCF, we choose the remaining numbers that are not common, that is xy. So answer is 8xy. But according to the question, what is given? A plus b is equal to 1/5 of their LCM. So it means a plus b is equal to 1/5 of LCM of a comma b. Now what is a? A is 8x plus 8y is equal to 1 by 5 of 8xy. So basically now, so this is equal to 8 gets cancelled, so therefore x plus y into 5 is equal to xy. So therefore this says 5x plus 5y is equal to xy. Done. Now So it turns out to be xy minus 5x minus 5y is equal to 0. So therefore, if we choose x common, y minus 5 minus 5 y minus 5 is equal to, I have added 25, so I'll say this side 25. Again, from here we can conclude x minus 5 into y minus 5 will be equal to what? That is equal to 25. Done. Now x comma y belongs to set of z plus. So we have to take the cases. What are the possible cases? So 25 can be written as 125, 25 1 or 5 5. No negative integers. Done. Let's check out the case. So first is x minus 5 is equal to 1, y minus 5 is equal to 25. Again this will be 6 comma 26. But HCF of 6 comma 26 is not 1. What we considered HCF of x comma y must be 1. But is it coming 1? No. Again with the similar case, x can be 26, y can be 6, but again not a possible case. Last case will be x minus 5 is equal to 5, y minus 5 is equal to 5. So basically x comma y will be 10 comma 10. Again not possible. HCF will not be equal to 1. So these are the possible cases and hence no solution. Hence no solution. Superb. So there are no integers a and b that satisfy this condition. Super. So answer will be what? Possible values for the sum a plus b? Only 0, since there are no integers. Done. Next question says, for any positive integer k, let h comma k is equal to HCF of k comma 90. Super. Calculate the value of summation s is equal to summation k is equal to 1 to 90 hk is equal to h1 plus h2 plus till h90. Okay, super. How do we approach? For approaching the problem, you understand what they are saying. H of k is equal to HCF of k comma 90. But if we are going for 1, 2, 3 and 90, it will be very hectic. It means first we have to find HCF of 1 comma 90, then we have to find HCF of 2 comma 90, then we are required to find HCF of 3 comma 90, and then we need to add up. So this becomes a lot tedious. So what's our approach? Instead of doing like this, we know that h of k is equal to HCF of k comma 90. Now if HCF of k comma 90 is there, so basically we are required to find HCF of each integer from 1 to 90 actually with 90 and then sum up and then add. That is the objective of the question. But is it possible? It will become very tedious if you start doing it individually. But what is the technique? Technique lies here. We can say 90 has prime factorization 2 into 3 square into 5. True or not? Correct. Now, so we can do one thing. Can we list the values of hk? Hk can be listed. Can be listed how? Can be listed as groupings. As groupings. Groupings means groupings based on HCF value. Based on HCF value. So why? Imagine 2 comma 90 and 4 comma 90 has both HCF as 2. Correct or not? Correct. So basically we can approach using a way of HCF and LCM. HCF of k comma 90 must be divisor of 90. True or not? Must be divisor of 90. Superb. So what are the divisors of 90? The divisors of 90 are 1, 2, 3, 5, 6, 9, 10, again 15, 30, 18 can be there, 30 can be there, 45 can be there and 90. So these are the only possible cases. Now we'll find k is equal to 1 to n, that is h of k, matlab HCF of k comma n will be calculated. How? We'll see how many divisors are there and we'll use phi of n by d. Now this is very important, and where d divides n. What does this mean? It means phi, this phi is Euler's quotient function. Amazing. Euler's quotient function. Now what is this Euler's quotient function? So for Euler's quotient function, it has some values. We'll see. First, we know the divisors. D. What are the possible values of d? So what will be the possible values of 90 by d, where n is 90. N is 90, and basically what we are doing, 90 by d. What are the possible values? It can be 90. It can be 45. It can be 330, it can be 18, it can be 15, it can be 10, it can be 9, it can be 6, 5, 3, 2, 1. So basically opposite. Okay, so what is Euler's quotient and why we are using Euler's quotient here? Actually, you think like this, why Euler's quotient? Now I will take some special classes for Euler's quotient individually, but you think of one thing, how to approach systematically Euler's quotient. Now phi of n, it means how many positive whole numbers less than equal to n are co-prime to m. That is the meaning of phi of n, are co-prime to n. Now co-prime means HCF is equal to 1. Okay, that is the meaning of co-prime. It means they don't share any prime factors. For example, if I say, let's say an example, n is equal to 6. So 6 prime factors. What are the prime factors? Prime factors are 1, 2, 3 and 6. So these are the prime factors, but which are co-prime to n. Okay, or numbers, how many positive whole numbers less than equal to n are co-prime to n? It means I have to list all the numbers. Instead of writing the factors, I'll list all the numbers. 1, 2, 3, 4, 5, 6. So which are the numbers that are co-prime to 6? So of course this is there. 3 cannot be there. 4 is not there. They are not co-prime. Why? HCF of 4 and 6 is 2. 5, 6 is there. 6, 6 is not there. Only 2. So phi of 6 is 2. Now but any easy way to calculate? Yeah, there is an easy way. Okay, well, again, not go into the derivations. We'll see what's the conclusion. P1 a per power 1, P2 a per power 2, and this goes on till Pk a per power k. P1, P2, Pk are distinct prime numbers. So here, therefore, phi of n can be written as n into 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3, and this goes on. So this is the way. Now what we are doing, phi of 6. So phi of 6, now 6 can be written as 2 into 3. So we'll say 6 into 1 minus 1 by prime factor, 1 minus 1 by second prime factor, and done. So this is 6 into 1 by 2 into 2 by 3. So basically answer is 2. And yes, phi of 6 was 2. Super. Now what we are calculating here? We are calculating HCF of k comma n. So basically HCF of k comma n, how we are going to calculate? Instead of calculating individual HCF, what we did? We saw the divisors. How many divisors are there? And we multiplied it with Euler's quotient function. So what is Euler's quotient function? Here Euler's quotient function of n by d. N by d means which are co-prime to n by d. We'll explore what am I saying. See here. Now if I calculate d into phi of 90 by d, why it's being like this? See here, suppose d is equal to 1, so 90 by d will be what? 90 by d will be 90. So phi of 90 by d will be, now what is, let me write systematically so that every time I don't need to write these things. Let's make a table. Let's make a table. So this is d, somewhere it will be 90 by d, then it will be phi of 90 by d, and then we will multiply d into phi of 90 by d. So why like this, you will understand. D is equal to 1, then 90 by d will be 90. Phi of 90 by d will be what? How do we calculate? So this will be phi of 90 by d, that is phi of 90. So 90, and 90 can be written as 18 into 5, that is 2 ka square, sorry, 18 into 5 matlab 3 ka square into 2 into 5. So basically 1 minus 1 minus 1 by 2, 1 minus 1 by 3, and 1 minus 1 by 5. So this will be 9, 1 by 2, 2 by 3, and 4 by 5. Done. So 3 to 6, 6 by 33. So this will be 24. So this is 24. Now what does this mean? It means phi of 90 by d means numbers which are co-prime to 90 by d. It means, what was d? What was d first? D is the divisor. So I am talking where the divisor is 1. So it means 90 by d will be 90. So therefore the value will be, what is the value? 24. Number of divisors is 1. So 1 into 24, the answer will be 24 here in this case. Okay. But you will be asking, sir, why we are doing this? I will illustrate. Think of this way. Okay, see what basically we are finding. We are finding S is equal to summation of k is equal to 1 to n and HCF of k comma n. That is what we are finding. So, and for k lying from 1 to n, k must be divisor. Matlab k must divide n. That is true. Now, say one divisor. Choose one divisor d. Say choose one divisor d. Now divisor d of n. Okay, so what we are required to do, we are required to find how many values of k, ठीक है, how many values of k where k lies from 1 to n such that HCF of k comma n is equal to d. That is true. That is our objective now. Now if HCF of k comma n is equal to d, then what are the conditions? Two conditions. What two conditions must be met? First, d must divide k. D must divide k. True. It means which implies k is equal to md for m belonging to z plus. True. Again, second, k by d and n by d HCF must be what? 1. It means what is k by d? K by d is m. M comma n by d must be co-prime. Okay, superb. Must be co-prime. Now how do we break this? We know k belonging from 1 to n. We know k is equal to m into d. So d into m. Md lies from 1 to n, which means m belongs to 1 to n by d. Okay. So these are the things. Therefore, for fixed divisor, any fixed divisor, d of n, so number of integers, what is basically written for any fixed divisor of n, what we are finding? Number of integers k. We are finding number of integers k that lies in the range where 1 to n and is equal to the number of integers m which lies in the range 1 to n by d. That is true, where HCF of m comma n by d is 1. HCF of m comma n by d is equal to what? 1. Now we know Euler's coefficient function. So what is Euler's coefficient function? What we are finding, number of integers m where m lies from 1 to x such that HCF of m comma x is equal to 1 is phi of x. That is the definition of Euler's coefficient function that I stated. Now therefore HCF of k comma n, that is number of k values, therefore remove it, number of k values for which HCF of k comma n is equal to d is what? Phi of n by d. That is phi of n by d. Why? Because m lies from 1 to n by d. So therefore HCF of m comma n by d is 1. So what we are talking? We are talking if the number of integers lies from 1 to x and HCF of m comma x is 1, that is co-prime. How do we calculate? We calculate with phi of x. And what is x? X is n by d. So therefore phi of n by d. So therefore sum will be, now what is sum? Sum is k is equal to 1 to n HCF of k comma n. So it means now we collect HCF of k comma n is equal to d. So let's say how many terms? Number of such terms is phi n by d. ठीक है, तो टोटल कितना हो जाएगा? So therefore for each divisor d of n, contribution to sum is d into number of times d appears in HCF. D appears in HCF. So this is equal to d into phi of n by d. So that's why, and if we do total, so therefore S will be equal to summation of d into phi of n by d. Now please do remember, you are not required to prove it unless until you go for advanced RMO problems. You are not required to prove it, just will find the value. So first is d 90 by d, phi of 90 by d. Let's calculate each value. Now phi of 90 by d, and here again next one, what we have written? D, then I have written 90 by d, and then I have written phi of 90 by d, and then I have written d into phi of 90 by d. Let's sum the value. For 1 it was 90, phi of 90 d was 24, so this is 24. Now divisor 2, so 90 by d is 45, so phi of 45 can be written as 3 chi square into 5. So basically this will be phi of 45 will be 45 into 1 minus 1 by 3, that is 2 by 3, and 4 by 5. So basically 5 3 15 3 24 again. So 24 into 2, this will be 48. Again for the third part, so 90 by 3, that is 30. So 30 can be written as 2 into 3 into 5. So basically 30 into 1 by 2 into 2 by 3 into 4 by 5. Done. So this will be 8. So d into 3 into 8, that is 24 here. Again for 5, so this will be 18. 18 can be written as 3 chi square into 2. So 18 into 1 minus 1 by 2, that is 1 by 2 and 2 by 3. So basically this will be 6. So 6 into 5 is 30 again. Next 6, 18 by 90 by 6, it will be 15. 15 can be written as 3 into 5. So again phi of 90 by d can be written as 15 into 1 minus 1 by 3, that is 2 by 3 and 4 by 5. So this gets cancelled, this will be 8. So 8 into 6 is 48. Again 6, after 6 it's 9, so this will be 10. So 5 of 10, 2 into 5. So basically 10 into 1 by 2 into 4 by 5. This gets cancelled 1. Again this is 4. So 9 into 4 will be what? 36. Again for 10 this will be 90 by 10, which is 9. Again 9 can be written as 1 minus 1 by 3. 9 is 3 ka square. So basically how many integers are co-prime to n? 9 and less than or equal to 9. So basically this will be 1 minus 1 by 3, that is 6. So this is 6. So 6 into 10 will be 60. Done. Now after 10 it will be 15. So this is 6, 2 into 3. So basically 6 into 1 by 2 into 2 by 3. Cancelled. Again this is 2. So total value is 30. Next 18. So this will be 5. So therefore number of co-primes that are number of integers that are co-prime to 5. So actually it is 1, 2, 3 and 4. So this will be 4 itself. This will be 4 itself. So 18 into 4 will be 72. Live after 18 this will be 30. So here it is 3. So actually how many integers that are co-prime to 3 and less than equal to 3? Only 2. So this will be 60. Again 45. So this will be 2. There is only 1. So this is 45. Again 91. So there is 1. Again 90. So what is the total summation? Total summation will be 24 and 48. So 72, 96, 126 and 164, 164, 170, 200, 260, 290, 362, 362 and 412, 412 and 90. So 412 and 90. So 502, 502 and this will be 45. No, 512 and 45. So 5 5 4 5 5 6, no 9, 150, 150, 195 was there, 195 and 225 was there, 225 and 295, 297, 297 and 357, 357, 387 and this was 387 and 48, 48, 96 and 48 again 144, 144 again 36, 180, 397 and 180, that is 567. So answer is 567. Superb, superb. Again an amazing question and really tough one. So these are the toughest of questions of HCF and LCM. So if you are a beginner, you see first two lectures, that will be suffice, or even you can see only the first lecture and skip through. But those who really want to deep dive into the IOQM questions and see what possibilities can it create for such new questions. Again, these questions are taken from my upcoming book, which will be released very soon. So now again an amazing question here. Next, so for the next one it says let h of n, okay, is equal to HCF of n per power 12 minus 1 comma n per power 20 minus 1. Now this question looks exactly alike. So instead of discussing so much, we can directly go on and see what can be done here. Now HCF is n to the power 12 minus 1, n to the power 20 minus 1, okay, for any integer n greater than 1. Super. What they are saying, find the number of integers n in the range of n lying from 2 to 100 such that n divides hn. Yeah, it's nearly the same question. So first, how do we approach? Again, the approach will remain the same. What we know HCF of solution. We know HCF of x to the power a minus 1, x to the power b minus 1 is equal to x to the power HCF of a comma b minus 1. Superb. Now we know h of n is given as n to the h of n is given as HCF of n to the power 12 minus 1 comma n to the power 20 minus 1. So now exponent is 12, b is 20. So therefore HCF of 12 comma 20, now this is 4, So therefore what we can say that it will be h of n is equal to n to the power 4 minus 1. But the condition says n divides hn. So it means n must divide n to the power 4 minus 1. So if n divides n to the power 4 minus 1, what does this mean? It means n to the power 4 congruent 0 mod or we can say n to the power 4 is equivalent to 0 congruent modulo n. So mod n. Done. Now what we can say, since n to the power 4 is a multiple of n, so basically this is true, this is true. So why? Because n divides n to the power 4. But what we require n to the power 4 minus 1 must divide n. This is what we require. Sorry, opposite. N divides, we can write n divides n to the power 4 minus 1. It means n to the power 4 is congruent modulo 1 mod n, that we require. But here we know this thing. So if we need both to be true, so what happens here? N shall be, so if n is a multiple of this, तो n to the power 4 क्या हो जाएगा? Congruent modulo 0 हो जाएगा mod n. So n can be written as, we can write in terms of this way, 0 minus 1 here, 0 minus 1 is congruent modulo 0 mod n, that is minus 1 is congruent modulo 0 mod n. So what is the conclusion? It means n must divide minus 1. That is the conclusion from here. N must divide minus 1. Now what are the integers that divides minus 1? Minus 1 and 1 are the only two integers. But what we asked, n shall lie from 2 to 100. Not possible. Not possible. No solution. So there is no solution. So number of integers 0. Number of integers is equal to 0. Super. Super. Next question says, let a comma b comma c be positive integers. Okay. A comma b comma c belongs to set of positive integers. Find the number of ordered triplet that satisfy the following condition. Amazing. There are 5 conditions that are given. HCF of a comma b comma c is equal to 10. LCM of a comma b comma c is 1200 and HCF a comma b is 20. HCF a comma c is 10 and HCF b comma c is 30. Now this is pure logic and amazing. And I will tell you, no questions. This is hashtag map. Why? No questions ever has been done like this. So please do pause, try to understand the question. Same type of question has been done, but actually there were only 3 variables that were taken care of. Now there are 6 cases. So and then see the solution. So basically what is written? 10. So 10 can be written as 2 to the power 1 into 3 to the power 0 into 5 per power 1. Okay. 1200 can be written as 12 into 100. So basically 100 is written as 2 chi square into 5 chi square, and 12 again, so 2 to the power 4 into 3 into 5 chi square. Done. Again 20 can be written as 2 chi square into 3 per power 0 into 5 per power 1. Again 30 can be written as 2 to the power 1 into 3 to the power 1 into 5 per power 1. Super. Now this is HCF of ABC, LCM of ABC, HCF again 20, 30 and there is 10. So I can also write 10. So 10 is already written, so therefore there is no problem. 10 is already written. Now it means there are only powers of 2, 3 and 5. So basically we can say A is equal to 2 to the power x1, 3 to the power y1, 5 to the power z1. B is equal to 2 to the power x2, 3 to the power y2, 5 to the power z2. ठीक है. C is equal to 2 to the power x3, 3 to the power y3, 5 to the power z3. Done. So these are the systems. Now Now what we are required to do, we are required to find prime 2 analysis for prime 2. So how do we analyze? We see HCF is given as ABC is equal to 10. Now this is 2. So it means what we are required to find, minimum of x1 comma x2 comma x3, that is 1. Okay, again LCM, so maximum of x1 comma x2 comma x3 is equal to 4. Done. Why? Here it is 4. Again minimum of x1 comma x2 is equal to 2. Minimum a comma c, to x1 comma x3 is equal to 1. Again minimum of x2 comma x3 is equal to 1. Now choose any one. I think this case can be chosen. So minimum of x1 x2 is equal to 2. So minimum of x1 x2 is equal to 2. What does this signify? That x1 shall be greater than equal to 2, x2 shall be greater than equal to 2. Superb. And minimum of x1 comma x3 is equal to 1. It means minimum. So if I am talking of minimum, it means x1 is greater than equal to 2. It means either x1 is equal to 1 or x3 is equal to 1, but x1 cannot be 1, so therefore x3 is equal to 1. Done. Now we have minimum of x1 x2 1 is equal to 1, which is satisfied in this condition. Now maximum of what is written, x1 x2 x3. Now we have concluded x3 is 1, so x1 x2 and 1 is 4. It means either x1 is equal to 4 or x2 is equal to 4. Done. So but how do we conclude? Now see here, x1 and x2. So where is written x1 and x2? So if x1, suppose if x1 is equal to 4, then what do we conclude? Minimum of 4 comma x2 is equal to 2, which is x2 is equal to 2. So therefore one of the triplet can be 4 2 1. Why? x1 is 4, x2 is 2 and x3 is 1. Second, if x2 is equal to 4, x2 is 4, then what are the cases? If x2 is 4, x3 is 1, then minimum of 4 comma x2. So therefore x1 will be 2 here. So this is 2 4 1. So two possibilities here. Again go for prime 3 and go for prime 2. Go for prime 5. So for prime 3, I'll do the analysis here. For prime 3, what are the conditions? Minimum of y1 y2 y3 will be 0, maximum will be 1. Again this will be 0. Okay, so minimum of y1 y2 y3 is 0, y1 comma y2 comma y3. Maximum of y1 comma y2 comma y3 is 1. Minimum of y1 comma y2 is 0. Minimum of y1 comma y3 is what? Minimum of y1 comma y3. So actually y1 is 10, so 0. Again it is 0. And minimum of y2 comma y3 is 1. So how to conclude? Now minimum of y2 comma y3. So y2 is greater than equal to 1. y3 is greater than equal to 1. Again from logical conclusion here, maximum of y2 comma y3, maximum of y1 y2 y3 is 1. So it means all must be less than equal to 1. Now condition, this two condition if combined, we can say y2 is equal to 1, y3 is equal to 1. So now minimum of y2, here it is given, minimum of y1 comma y2 is equal to 0. So basically it means minimum of y1, so y1 must be 0. Why? y2 is 1. So basically what are the possible triplets? So 0, 1, 1. That is the only possibility for this triplet. Now again, let's check for 5. So for prime 5, what we can do? What was the minimum value? 1. Again, maximum was 2. Again, minimum 1. 1, 1. Okay. For everywhere it is 1. So minimum Z1, Z2, Z3. Okay. It was 1. Maximum of Z1, Z2, Z3. It was 2. Again, minimum of Z1, Z2 is 1. Minimum of Z1, Z3 is 1. Minimum of Z2, Z3 is 1. Now, how to deduce? First is written minimum of Z1, Z2, Z3 is 1. It means Z1 greater than equal to 1, Z2 greater than equal to 1, Z3 greater than equal to 1. Super. Now, maximum of Z1, Z2, Z3 is 2. It means one of the exponents is 2. One of the exponents is 2. Superb. One of the exponents is 2. Again, the other minimum condition says Z1, Z2 greater than equal to 1. Similarly for this one. Again, similarly for this one. So, what are the possibilities? It means either two of them are 1 and one of them is 2. Either no. This is the only condition. But they can have the cyclicity. It means 2, 1, 1 can be one of the case. 1, 1, 2, 1 can be one of the case. And 1, 1, 2 can be another case. Done. So these are the three possible cases for exponents of 5. Three possible cases for exponents of 5. Exponents of 5. Done. Superb. So what is the final number of case? So total number of ordered triplets. Total number of ordered triplets is equal to what? Total number of ordered triplets A, B, C will be equal to, so here it was 2 cases, here it is 1, here it is 3. So 2 into 1 into 3, that is equal to 6 cases. Now there is another condition actually written, LCM of A, B is greater than 1000. So is this justified? By all these 5 cases, will the 6th case will always be true? Actually it will be. So that's why I didn't discuss about LCM of A, B is greater than 1000. How? Let's see. Suppose exponents of x1, x2 was minimum 2, 4. y1, y2 was say 0, 1. And z1, z2 was 1, 1. Now it is like that. So LCM of A, B will be, so 2 to the power 4. Now y1, y2 is again 3 per power 1, again 5 per power 1. So this will be what? This will be 240. But actually it isn't right. Why? Because the combinations are not perfect. LCM will depend upon the specific combination. Specific combination means, for example, if I choose one of the specific condition, you can't go for all the combinations. Now combination will be specific for each one. For example, if I am choosing 4 to 1, 4 to 1 is the triplet. 4 to 1 triplet, it means, and suppose there can be another triplet 0, 1, 1. For this 0, 1, 1 is the only triplet. Yeah, 0, 1, 1. Now choose another triplet, that is 2, 1, 1. So what is A? A will be 2 to the power 4, that is 16, 3 to the power 0 and 5 to the power 2. So 16 into 25. So what is 16 into 25? So 16 into 25 will be 250, 25 is 400. And what is B equal to? So B will be equal to 2 to the power 2, which is 4 into 3 into 5. That is equal to what? 5, 4, 20, 23, 60. And what is the LCM of 60 and 400? So basically LCM will be 1200. LCM will be 1200, which is always greater than 1000. So what I am saying, all the 6 cases are valid, but it depends upon the specific combination. So therefore this is true. So number of ordered triplets is 6. And that brings to the end of this discussion. HCF and LCM is complete, and this was an amazing session. You need to see all the videos and then you will be an expert in HCF and LCM. Thank you.